So our last video about radicals is about the domains of our radical functions. So with a radical function, remember, we have to pay attention to the domain, especially with our even roots. So the domain of a radical function is going to be what x's we're allowed to plug in. Remember, domain is our possible x values. And before, when we were talking about the square root of x, the domain was 0 to infinity, right? We had our cute little graph that did this. Now, we could regraph these. We could, as one possibility, we could put these into our calculator and then see what happens with our calculator table when it starts acting funny. But another easy way is to just remember we can't take the square root of a negative. So our radicand, what's inside of our radical, should always be positive. So a way to figure out your domain is to just take your radicand and set it greater than or equal to 0, and then solve. So in this case, our answer is x has to be greater than or equal to -2, which we can go ahead and put in interval notation if we want to, because we became very good at that back in the last section. All right, so that's one. It doesn't matter if there's something happening outside. So I could change this equation up, and I could make this f of x is equal to 3 times the square root of x plus 2 minus 7, all divided by 15. Nothing changes it, because the only place that we're going to get an error is if there's a negative inside of the radical. So even if I make it super complicated, the only thing you need to look at is what's inside your radical symbol. All right. So the next one, I want you guys to pause video and try on your own. See if you could do that. So now we're looking to make this radicand, or this inside, greater than or equal to 0. Takes a little bit more math, but it's exactly the same steps. We have 2x is greater than or equal to 3. And then x is greater than or equal to 3 halves. And if we want to write this as our interval notation, 3 halves up to infinity. The last one here is a bit of a trick question. With our cube roots, it's actually completely okay to take the cube root of a negative number. The cube root of -8 is -2. And that's because if we were to check this, -2 cubed is equal to -2 times -2 times -2, which is -8. We have an odd number of negatives, so while these two negatives may combine to a +4, we then have a positive times a negative, which is negative, right? So anytime we have an odd index, any odd index, we don't have any problems. We can plug in anything we want, and our answer for our domain is going to be -infinity to infinity. We can plug in anything. All right, so I'm going to finish up this video, but I'm going to have you do one more. Let's do k of x is equal to the square root of 3 minus x, and then a +5 outside of the radical. I want you guys to try that out. It's a little bit more challenging than the last one. All right, so again, we'll be looking at our radicand. 3 minus x is the only piece we care about. It has to be greater than or equal to 0. Issue here is that you need to pay attention to the fact that we have a negative on our x. So you have two ways you could solve it. If you want to leave the x where it is, you can go ahead and subtract 3 from both sides, leaving us with a -x is greater than or equal to -3. And then we need to make sure that we remember what we did back when we solved inequalities back in the past. If we divide by a negative, we need to rewrite this with a flipped inequality, so x is less than or equal to 3, which makes sense, right? If we're dealing with 3, we can't subtract anything bigger than 3, or else it would be negative. And then our interval notation would be -infinity up to 3, but nothing higher than that. So again, if you need a little recap of the interval stuff, you go back and review that. But otherwise, this is all there is to domains of our radical functions.